All right, so if you've ever built a web app, you're probably a pro with tools like PostgreSQL and Elasticsearch. You know your way around structuring and searching for data. But when you start building for AI, you realize pretty quickly that you need a completely new kind of foundation.
So let me just ask you this. You're building those next-gen AI features, right? We're talking smarter search, better recommendations, maybe even an app using retrieval augmented generation, or RAG. Are your go-to traditional tools really ready for that challenge? Well, the short answer is probably not.
Okay, let's really dig into this. What we're running into is something people are calling the AI infrastructure gap. And it's basically this fundamental mismatch between how our trusted old school databases think about data and how modern AI models actually understand the world. They just speak different languages. And here it is, the heart of the problem. Traditional databases, they are absolutely brilliant at exact matches. You write a SQL query for the word apple, and it finds apple. It's precise, it's structured. But AI models, they think in terms of meaning. They understand that healthy snack is related to apple, even though the words don't match at all. It's a totally different way of organizing information, and that's why it needs a new kind of tool. So how in the world do we bridge this gap between rigid, structured queries and this fuzzy world of semantic meaning? The answer is a purpose-built solution, the vector database. And the absolute key to understanding vector databases is understanding the new kind of data they're built to manage, embeddings. So what exactly are embeddings? Well, you can think of them as the native language of AI. They're basically these numerical representations, just long lists of numbers that we call vectors. And their job is to translate a concept, like a word, a sentence, or even an image, into a format that captures its true meaning. Here's what that looks like in practice. A traditional database, it just stores the text apple. Simple. But a vector database stores this complex vector that's been generated by an AI model. And here's the magic. This vector places apple in a kind of high-dimensional space where it's mathematically super close to things like fruit and banana, but incredibly far away from car or computer. It's all about context, but encoded in math. The classic example. And there's a good reason it's so famous. It shows that embeddings aren't just random numbers. They actually encode relationships. I mean, the vector math here literally captures these abstract concepts of gender and royalty. When you can start doing math on ideas, well, that's when you can build some truly intelligent applications. Okay, so we get embeddings, but how does a vector database actually use them? Under the hood, it all really boils down to a core stack of 4 essential components. So first, you need the embeddings themselves, which you create from your data using an AI model. Second, you have the vector index. This is the secret sauce, really. It organizes millions or even billions of these vectors, so you can search them incredibly fast without having to check every single one. Third, you've got a storage layer to actually hold on to the vectors and any metadata. And finally, the query engine, which takes your search vector and efficiently finds its closest neighbors in that index. Now, it's so important to understand where this new tool fits in your stack. A relational database is for your transactions and exact matches. A search engine like Elasticsearch, it's great for keywords. But a vector database is built for one job: finding semantic similarity at a massive scale. It is not meant for your ACID transactions, those guaranteed reliable data operations. So it doesn't replace your existing stack, it complements it. It adds a brand new capability specifically for AI. All right, that's enough theory. Let's talk about what this technology actually does. Let's look at some real-world use cases where vector databases are solving huge problems right now. First up, semantic search. And this is a total game changer. Just imagine a user searching your help docs for how to reset my password. A simple keyword search might totally fail if your article is called changing your account credentials. But a vector database gets the intent behind the search. It knows those 2 phrases mean the same thing, and it serves up the correct document. This is all about relevance, not just matching text. And then you have retrieval augmented generation, or RAG, which is the engine behind so many of today's AI apps. Look, an LLM like GPT-4 is incredible, but it has no idea about your company's private data. So with RAG, when a user asks about your specific refund policy, the vector database first retrieves the relevant policy doc from your private knowledge base, and then it feeds it to the LLM as context. This is exactly how you get accurate, grounded, and safe answers from large language models. And hey, if you're thinking, is this just hype?
Just look at this number. A 400% jump in job descriptions mentioning vector database in a single year. The market is practically screaming for people with these skills. This isn't a nice to have anymore. It's quickly becoming critical infrastructure and a core skill for any developer building with AI.
So you've got the theory. Now what? Well, the most important thing you can do is move from theory to practice. Let's make this real. Let's talk about what you can do like this week to actually get started. Here is your action plan for this week. It's simple. First, try explaining this to someone else. It's the absolute best way to make sure you've got it down. Second, go sign up for a free managed vector database account, something like Pinecone. Third, just follow their quick start guide. Seriously, in about 30 minutes, you'll have inserted and queried your first vectors. And finally, play around with an API like OpenAI's to generate your own embeddings from some text. In just a few hours, you can have a real working prototype. You know, most developers are still just getting up to speed on this stack. By taking these first steps right now, you are putting yourself way ahead of the curve. Mastering this isn't just about learning another tool. It's about understanding the fundamental infrastructure for the next wave of applications. Your competitive advantage in this AI era, it truly starts right here.